All right, graphing quadratic functions. So vertex formula, you can find the vertex when it's already in standard form for the quadratic. Now, the truth is you could actually just use completing the square and go from there. But you can also use the vertex formula right here. Okay, negative b over 2a. That is the x value. And then this is showing f of this value, meaning that once you find the x, you just plug it back into the function and then see what your corresponding y value is. That's all that's saying, okay? Because once you know your x value, yeah, it would make this true. You just got to find its corresponding y value. Don't worry that it says a is never 0, because if it was, then it's a straight line, not a parabola. So this part is really insignificant because we're dealing with quadratics, but for math nerds it is. Now again, if a is positive here, then the graph opens upwards. If it's negative, then it opens downward. We don't really care about that. We just want to know what the vertex is. All right, so here we go. Consider this quadratic. We want to find the vertex, right? So let's use the vertex. So the vertex can be found just by, well, first I would solve for the x value. Now this one, it's not showing a b value for us, but there is a b value there. This could be rewritten as 9x squared, and you can keep your minus 49 there, but the middle term here would be a plus 0x. Okay, so again, this is just to have an a and a b value. So if I wanted, because I do want to find the x value, the x will be negative b over 2 times whatever the a value is. Okay, so the b we see is that 0. And then the a value showing as 9. I think some of you realize that the 9 isn't going to be significant here because 0 divided by anything is 0. Which means that in my ordered pair for my vertex, I just found that my x value is 0, right, for my vertex. Well, if x is 0, then I go back to the equation here. This is solving for the corresponding y value. So I take my equation, which is f of x equals 9x squared minus 49, and I simply replace the x with 0. And this would tell us that f of x, which is really just y, equals 9 times 0 squared minus 49 is going to be just negative 49. So I get a vertex of 0, negative 49. So that's my vertex. We just found it. I'll box it in. Next, it says, so we did find the vertex. The x value, though, the x value of its largest x-intercept is x equals something. Okay, so the x-intercept, what do we know about the x-intercept? Well, at the x-intercept, the y is 0, okay? So this means that if you were to take the equation, let's take the original equation, and this should hopefully look familiar, but then we get a 0 equals 9x squared minus 49. So to solve this one, it looks like a difference of squares, and well, it is, because 9x squared would be the same as taking 3x squared, and 49 is, 7 squared. So this is a difference of squares situation, and I'm specifically taking the shortcut to just save us a little bit of time. But this then becomes, remember it's always minus and plus, just the two bases there. So I got 3x and 7. So to find the x-intercepts, we just solve these for x. Okay, so let's solve those. I guess I'll do purple. So this 3x minus 7, if I could get that to equal 0, that would be true. So add 7. Sorry, it's kind of small there, but hopefully it makes sense. So we got 3x equals 7, and then divide both sides by 3. And I get a corresponding x value that is 7/3. Okay, so one of my ordered pairs for the x-intercept would be 7/3, 0. Let's solve for the other one, though. Okay, so again, if I could get 3x plus 7 to equal 0, then it would be true. So minus 7 from both sides. Now I get 3x equals negative 7, and then divide both sides by 3. Tells us that x could be negative 7/3. So again, as an ordered pair, the other x-intercept would be negative 7/3, 0. It asked specifically, though, for the largest. And while they look the same, one's positive, one's negative, positives are always larger than negatives. So this would be the one that's largest. The value of the y-intercept, this one came equipped with the y-intercept as the vertex right there. So the value of the y-intercept, we already know it. It was just at the vertex. Now, some students are like, well, how did you know this was at the vertex is the y-intercept? Because the x is 0. Once we knew that the x was 0, this was also the y-intercept, and so the vertex just happens to be the y-intercept on this one as well. Will that happen always? Probably not, but it could.